From this video, we shall learn how to solve the system of linear equation by using Gauss-Jordan elimination method. Like the video, subscribe to the channel, share this video link with your maximum number of friends, gain the knowledge and rule the world. Solve the system of equation 2x1 plus x2 plus 4x3 equal to 12, 4x1 plus 11x2 minus x3 equal to 3, 8x1 minus 3x2 plus 2x3 equal to 20 by using Gauss-Jordan elimination method. So they have given 3 equations and 3 unknowns. Solution: consider 2x1 plus x2 plus 4x3 equal to 12. Then the second equation, 4x1 plus 11x2 minus x3 equal to 33. And the third equation, 8x1 minus 3x2 plus 2x3 equal to 20, and call all together as equation 1. It is the equation 1. The augmented matrix is given by A colon of B equivalent to, where A is the coefficient matrix of a given equation and B is the constant matrix of a given equation. So A matrix will be 2, 1, 4 for the first equation, and 4, 11, minus 1 will be for the second equation, 8, minus 3, 2 will be for the third equation, and the B matrix will be 12, 33 and 20. Both together we write as an augmented matrix A colon B equivalent to 2, 1, 4 colon 12, 4, 11, minus 1 colon 33, 8, minus 3, 2 colon 20. It is the augmented matrix which we have got by using the equation 1, that is the system of linear equation 1. Consider the augmented matrix. Now we need to apply the first step of a Gauss-Jordan elimination method. The first step of a Gauss-Jordan elimination method says that we need to use the element A11 not equal to 0 to make the element A21 and A31 to become 0 by using row elimination method. Augmented matrix A colon B equivalent to, so we are using the element A11 and making A21 and A31 to become 0. Therefore the first row will be unaltered. For that purpose, write the first row as it is, 214 colon 12. Now we need to make A21 as 0. So A21 here is nothing but the first element of the second row and it is 4. The 4 has to be made 0. How we can make 0? By subtracting it minus 4. So here the first element of R1 is 2. So 4 minus 2 will be just 2, but we want there 4. That means what? If that 2 has been multiplied by 2, then it will become 4. So 4 minus 4 will be equal to 0. That means what? 2 has to be multiplied by minus 2. Therefore what we can write? R2 equal to R2 minus 2 R1. R2 minus 2 R1. While saving, we say as an equal to, but while writing we need to write the arrow mark. That means R2 will be transferred to as R2 minus 2 R1. So R2 first element is 4 minus 2 into R1 first element is 2. Minus 2 into 2 is minus 4. 4 minus 4 will be equal to 0. Then next, R2 second element is 11 minus 2 into R1 second element is 1. 11 minus 2 into 1. Minus 2 into 1 is minus 2. 11 minus 2 is 9. The next, minus 1 is there. That is the third element of R2. And the third element of R1 is 4. Therefore what we can write? Minus 1 minus 2 into 4. Minus 2 into 4 is minus 8. Minus 1 minus 8 will be equal to minus 9. Colon. Fourth element of R2 is 33 and fourth element of R1 is 12. So that is 33 minus 2 into 12. Minus 2 into 12 will be 24. 33 minus 24 will be equal to 9. 33 minus 24 equal to 9. Then next we need to make A31, that is 8 as 0 by using A11. So A11 is 2. When we multiply that one with minus 4, then it becomes minus 8. So 8 minus 8, it will become 0. Therefore we can write R3 equal to R3 minus 4 into R1. R3 equal to R3 minus 4 into R1. So first element of R3 is 8 minus 4 into first element of R1 is 2. 8 minus 4 into 2. Minus 4 into 2 is 8. 8 minus 8, 0. The next second element of R3 is minus 3 and second element of R1 is minus 4. So second element of R1 is 1. Right. So minus 3 minus 4 into 1. Minus 4 into 1 is minus 4. Minus 3 minus 4 will be equal to minus 7. Then next third element of R3 is 2 and third element of R1 is 4. So 2 minus 4 into 4. 4 into 4 is 16. Since it is a minus, it will be a minus 16. 2 minus 16 will be equal to minus 14. Colon. Fourth element of R3 is 20, whereas the fourth element of R1 is 12. So we can write 20 minus 4 into 12. Minus 4 into 12 will be equal to minus 48. 20 minus 48 will be equal to minus 28. So this is the augmented matrix form which we get after applying the first step of Gauss-Jordan elimination method. It is the augmented matrix which you have got after applying the first step of Gauss-Jordan elimination method, and here you can observe the second row is divisible by 9 and third row is divisible by 7. To make the simplification very easier, we divide the second row by 9 and third row by minus 7. Therefore the augmented matrix equal to, the first row is unaltered, write it as it is, 2 1 4 colon 12, whereas the second row we are going to divide it by 9. Therefore what we can write, R2 equal to 1 by 9 into R2. 1 by 9 into R2. So 1 by 9 into 0 will be 0. 1 by 9 into 9, 9 9 cancel, 1 into 9 is 9 9 cancel, 1 into 1 is 1. Then 1 by 9 into minus 9, 9 9 cancel, 1 into minus 1 will be equal to minus 1 colon. Then 1 by 9 into 9, 9 9 and cancel, 1 into 1 will be equal to 1. Now R3. So in the R3 it is divisible by 7. Since all are negative, we can write as R3 equal to minus 1 by 7 into R3. R3 equal to minus 1 by 7 into R3. This is multiplying row 3 by 1 by 7. So minus 1 by 7 into 0 will be 0. Minus 7 into minus 1 by 7. That is the minus 1 by 7 into minus 7. 7 7 cancel. Minus 1 into minus 1 will be equal to plus 1. Then minus 1 by 7 into minus 14. So 7 1s are 7 2s are. So we will be having minus 1 into minus 2. It will be equal to 2. Then colon, fourth element minus 28 is there. So minus 1 by 7 into minus 28. 7 1s are 7 4s are. So it will be minus 1 into minus 4. It will be plus 4. So it is the augmented matrix which we have got after dividing R2 by 1 by 9 and R3 by 1 by 7. Now we shall apply the second step of Gauss-Jordan elimination method to make the element using A-22 and making the element A12 and A-32 to become 0. So here all the elements are 1, that is the second elements are 1. So it is easier to make them as a 0. So write the augmented matrix A colon B equivalent to. So now here Second row is unaltered. For that purpose, write the second row first. 0, 1 minus 1 colon 1. Now, using the second element of R2, that is the 1, you have to make the second element of R1, that is 1, as 0. So what we can write? R1 equal to R1 minus R2. R1 equal to R1 minus R2. So R1 is 2, first element, minus R2 first element is 0. 2 minus 0, 2. And next, R1 first element is 1 minus R2 first element is 1. So minus 1 into 1 will be minus 1. 1 minus 1, 0. Then next, third element of R1 is 4 minus 1 into R2 element is minus 1. Minus 1 into minus 1 will be plus 1. 4 plus 1 will be equal to 5. Colon. Fourth element of R1 is 12 minus 1 into fourth element of R2 is 1. Minus 1 into 1 will be minus 1. 12 minus 1, 11. Now we need to make the second element of a third row as 0. So it will be just 1 minus 1. That means we can write R3 equal to R3 minus R2. It is just multiplying R2 by minus 1. So third row first element is 0 minus first element of second row is 0. Therefore 0 minus 0, 0. Then second element of R3 is 1 minus 1 into second element of R2 is 1. So minus 1 into 1 will be minus 1. 1 minus 1, 0. Then R3 third element is 2 minus 1 into R2's third element is minus 1. Minus 1 into minus 1 will be plus 1. 2 plus 1 will be equal to 3. Colon. Fourth element of R3 is 4 minus 1 into fourth element of R2 is 1. So minus 1 into 1 will be minus 1. 4 minus 1 will be equal to 3. So it is the augmented matrix which we get after applying the second step of Gauss-Jordan elimination method, which says using the element A dash 2 2 not equal to 0 by making the element A 1 2 and A dash 3 2 to become 0 by using row elimination method. Now this is the matrix which you have got after applying the second step of Gauss-Jordan elimination method. You can observe the third row is 0 0 3 colon 3. This one you can divide by 3 so that you get the smaller numbers. It will be 0 0 1 1. That is R3 can be done as R3 into 1 by 3. So then it will be 0 0 1 colon 1. Then it will be simple for the purpose of doing the calculation. Since a 3 is not a big number, I have not divided. You can divide and then you can do the further step also. In this case, I have not divided. I am considering the same as 0 0 3 and 3 itself. So augmented matrix A colon B equivalent to. Now the third step says that we need to use A double dash 3 3 to make the element A dash 1 3 and A dash 2 3 to become 0 by using row elimination method. So that is the third row will be unaltered. For that purpose, write the third row as it is, that is 0 0 3 colon 3. If you have divided, then it will be 0 0 1 colon 1. Now the third element of R1 is 5 and you have to make this one as 0 by using 3. So 5 minus 3 will be 2. If you multiply the third row by any value, it will be not equivalent to 0. So what you have to do is, you have to multiply the coefficient of a third element of row 1 to R3 and coefficient of third element of R3, that is the row 3 with R1. That is, we can write R1 equal to 3 into R1 minus 5 into R3. That is multiplying the third element of R3 to R1 and multiplying the third element with a minus sign of R1 to R3, that is 3R1 minus 5R3. So now the third element, the first element of R1 is 2. So 3 into R1, that is 3 into 2 is 6, minus 5 into R3. R3 is 0. So 2 into 3 is 6. 6 minus 0 is 6. The next second element of R1 is 0. 3 into 0 is 0, minus 5 into second element of R3 is 0. So 0 minus 0, again 0. 3 into 0 is 0, minus 5 into 0 is 0. 0 minus 0 is 0. Then the third element of R1 is 5. So 3 into 5 is 15, minus 5 into third element of R3 is 3. So minus 5 into 3 is minus 15. 15 minus 15 will be equal to 0. That means what? We have used the element A double dash 3 3 to make the element A dash 1 3 to become 0. That is, by using element 3 we have made the element 5 as 0. Colon, the next 3R1. So 3 into fourth element, that is 11. So 3 into 11 is 33, minus 5 into fourth element of R3 is 3. So 5 into 3 is 15. So 3 into 11 is 33, minus 5 into 3 is 15. 33 minus 15 will be equal to 18. 33 minus 15 equal to 18. Then now we need to make a minus 1 as 0, that is A dash 2 3 as 0 by using 3, that is A double dash 3 3. So now what we can do is we can multiply with the R2 can be multiplied with 3, right, whereas R3 can be multiplied with 1. That is, we can write R2 equal to 3R2 plus R3. R2 equal to 3 into R2 plus R3, because you can observe the third element of the second row, it is minus 1. So 3 into minus 1 will be minus 3 plus R3, third element is 3. Minus 3 plus 3, it will become 0. For that purpose R2 equal to 3R2 plus R3. So now do the calculation. So the first element of R2 is 0. 3 into 0 is 0, plus R3 first element is 0. 0 plus 0, 0. Then next R2's first element is 1. 3 into 1 is 3, plus second element of R3 is 0. 3 plus 0 is 3. Then the third element of R2 is minus 1. 3 into minus 1 is minus 3, plus third element of R3 is 3. Minus 3 plus 3 will be equal to 0. Colon. So what we have made? We have made A dash 2 3 to become 0 by using A double dash 3 3. Right? What is what? The third step of an Gauss-Jordan elimination method. Next, fourth element of R2 is 1. 3 into 1 is 3, plus fourth element of R3 is 3. So 3 plus 3, 6. So we have got an diagonal matrix for A. Right? The augmented matrix, you can observe the coefficient of the equations. There is a matrix A. Now it is a diagonal. That means after the third step we get the diagonal matrix, and now we shall move on to the third step. So this is the augmented matrix which we have got in the third step. Now by using this augmented matrix in the fourth step, we need to write that one in the form of an equation. That is, from the above augmented matrix we get the first row is 6 0 0 18. That means 6 into x1 plus 0 into x2 plus 0 into x3 equal to 18. So in x2 multiplied by 0 will be 0, that we neglect. x3 multiplied by 0 is 0, that we neglect. So therefore we write only 6x1 equal to 18. Then second row is 0, 3, 0, 6. 0 into x1, that we neglect, plus 3 into x2 plus 0 into x3 is 0, that we neglect. Therefore we consider only 3x2 equal to 6. Then 0, 0, 3, 3. So x1 into 0 will be 0, that we neglect. x2 into 0 will be 0, that we neglect. 3 into x3, that we write is equal to 3. That means we write 3x3 equal to 3. It is the fourth step of Gauss-Jordan elimination method. So whatever the equations we have got in the previous step, those equations you have to consider, and we will get the values of x1, x2 and x3. Consider the first equation, 6x1 equal to 18. So this can be done as x1 equal to 18 by 6. 6 ones are 6 threes are 6 ones are 6 threes are 18. Therefore 6 ones are 6 threes are. Therefore x1 equal to 3. It is the value of x1. Next is we need to calculate the value of x2. Consider the another equation, 3x2 equal to 6. It can be done as x2 equal to 6 by 3. 3 ones are 3 twos are. Therefore x2 will be equal to 2, because 3 ones are 3, 3 twos are 6. So 3 ones are 3 twos are 6. Therefore x2 will be equal to 2. Now next we need to calculate the value of x3 by considering the another equation, and that equation is 3x3 equal to 3, and it can be done as x3 equal to 3 by 3. 3 and 3 cancel, that is 3 ones are 3 ones are. Therefore x3 will be equal to 1. So these are the values of x1, x2 and x3. Therefore x1 equal to 3, x2 equal to 2 and x3 is equal to 1 are the exact solution of the given system of linear equation 1 by using Gauss-Jordan elimination method. We can do the verifications of the answers what we got with the equations which have been given in the question. So that verification can be done for purpose of checking whether we got the correct answer and it not to be written in an examination. Of x1, x2 and x3 we got are x1 equal to 3, x2 equal to 2 and x3 equal to 1. Now the first equation is 2x1 plus x2 plus 4x3 equal to 12. Consider LHS. It is the left hand side of the equation, and that is 2x1 plus x2 plus 4x3. Now substitute the value of x1, x2 and x3 in this equation. So it will be equal to 2 into 3 plus 2 plus 4 into 1. So 2 into 3 is 6. So we can write equal to 6 plus 2 plus 4 into 1 is 4. So 6 plus 2 is 8, 8 plus 4 is 12 equal to 12. Therefore it is RHS. LHS is equal to RHS. That means whatever the values we have got are correct according to the first equation. Now consider the second equation. Second equation is 4x1 plus 11x2 minus x3 equal to 33. Consider LHS, left hand side of an equation, 4x1 plus 11x2 minus x3. Substitute the value of x1, x2 and x3. We can write equal to 4 into 3 plus 11 into 2 minus 1 equal to 4 into 3 is 12 plus 11 into 2 is 24 minus 1. 4 into 3 is 12 plus 11 into 2 is 22. Sorry, I have told 24. It is 22. 11 2s are 22 minus 1. So 12 plus 22 minus 1. 12 plus 22 is 34. 34 minus 1 is 33. That is what? RHS. LHS is equal to RHS. That means the answers what we have got is correct for the second equation also. Now we shall verify for the third equation. Consider the third equation. Now consider the third equation. The third equation is 8x1 minus 3x2 plus 2x3 equal to 20. Consider LHS. 8x1 minus 3x2 plus 2x3. Now substitute the value of x1, x2 and x3. So it will be equal to 8 into 3 minus 3 into 2 plus 2 into 1. 8 3s are 24 minus 3 2s are 6 plus 2 1s are 2. 24 minus 6 plus 2. 24 minus 6 will be 18. 18 plus 2 equal to 20. That is, we have got RHS. LHS is equal to RHS. That means whatever the answer we have got, that have been correct for all the equations which has been given in the question. That means the answer which we have got or the exact solution of given system of linear equation 1 by using Gauss-Jordan elimination method. Like the video, subscribe to the channel, share this video link with your maximum number of friends, gain the knowledge and rule the world.